Okay, we're back to counters again. Here we go. This is counters part 2. We're going to be talking about counter downs now. So what do we got to do here to get counter downs to work? So let's see here. Let's throw one of these pieces in there. Let's go over here to counters. CTD is what we're looking for this time. Again, we're going to grab that counter address. So I'm going to come in here, grab counter, say counter 0 for instance. I'm going to grab some address here. Let's see here. I can just grab some binary address to toggle back and forth. I love that. And as you can see here, I got the I's here, indicating that what? I made an online edit. So in order to get this thing to accept this, I have to download this information using that arrow. At that very moment now, as you can see here, my counter down is enabling the program. It's in the PLC. If I come over here and hit the Control T for toggling that back and forth, we will see what is it doing now. It's counting down. As you can see, that accumulated value was set to 0. So what it's going to do is, first thing it's going to do is go to negative numbers. I'm going to enter a value of, say, 10 in there. As you can see, when I hit 10, as soon as I enter 10, the done bit turns on. And then I'm going to hit the Control T, and you're going to see it count down from there. Control T, excuse me. Oh, I've got to have this highlighted. As you can see, it's counting down as fast as that. And to 0, then again back to negative 1. Okay. So what do we learn from this experience already? That the accumulated value does what? It goes down. So if it's set to 0, it goes negative 1. So you can imagine when I incorporate another rung of logic, I'm just going to go offline this time, create another logic here. And this time I'm going to incorporate the reset for this. I'm going to grab binary 1 this time. And I'm going to grab the same address for the counter. And download that. So now, what's going to happen here, if I put a value, say, let's go 12 in here. You can see a done bit turn on right away. I'm going to go ahead and toggle this back and forth. Control T. Counting down, bam. Okay, so now the done bit is off. And what's going to happen when I hit that reset? What do you think is going to happen when I hit binary 1? When I toggle binary 1 on, it's going to what? It's going to set the accumulated value to what? Not the preset value, but to 0. So what does that mean for us? If we do the reset to a countdown timer, a counter, excuse me, a CTD, when I hit the reset, it sets it to 0. So once it's set to 0, do you think that done bit will ever turn on again? It's not going to happen. Why? Because it's got to be equal to or greater than. Remember that statement? So it's got to be equal to or greater than 10. So it has to be a value greater than 10. So the second I type in a value of, say, 20 in here, oh, look at that, it's setting it to 0. Why is it doing that? Well, because I left this toggle on. This Control T here. Put a value of 20 in there now. Bam, that done bit turns on immediately. So what's happening here is this accumulated value is greater than the preset value, so the done bit is on. And then when I would count it down to 10, for instance, I'll put 15 in there so I don't have to count it. Toggle so much so my finger doesn't fall off. Control T. Oh, I gotta highlight this. 10. I toggle it one more time, that done bit turns off. Bam. There she goes. So now the value is the done bit's not on. If I come down here and toggle this guy, it goes back to 0. So these are all points I need you guys to be aware of when you're dealing with ladder diagrams, when you're dealing with exam time. You're going to see examples of this. You need to understand that what happens when it counts down, when you hit that, when you hit this input, what is that accumulated value going to do? What's that done bit going to do? So let's just continue on with the same process we did before, where I created some I want to create this. Oh. There we go. Counter 0. I'm going to use the done bit here. How about the counter up bit? We'll use the counter up bit first. Binary, I'm using 0, 1, let's use 2. Let's duplicate this, copy run. Paste the run. Oh, I use CU. That's what I use CD because we're counting down. Knucklehead CD. That's the one we gotta have, not CU. Dude, that's pretty. You got that one wrong. So then we want to use the done bit here. So we want CD and we want the done bit. Here we want binary 3. So I got binary 0, binary 1, binary 2, binary 3. So we're going to go ahead and download this information. Okay, so now we're looking at this. We're looking at all the bits associated with this counter 0, counter down 0 at that. I'm going to put a value of, say, 11 in here, just so we got one value over that. So now, as you can see, as soon as we reach the value above 10, we get the done bit. The done bit's turning on binary 3. If we look at the controller tags, we go to the counter 0. We grab that information like we did in the past. We can see that the preset is to 10, the accumulated value is 11, and done bit is on. So as it's a true representation of what's going on here. So now if I trigger this binary bit, control toggle that, as you can see now it's equal to 10, done bit's still on. Oh, and the CD turned on at the same time. You notice the CD was on, so binary 2 was on as well. I'll do that experiment again so we can see that. So when we are toggling this on, when this guy is on, CD is on. CD turns this bit on, turns this output on. Done bit is on, turning on this contact, turning on this output. So we are in pretty good shape here. Everything is on. So then I'm going to come in here, I'm going to toggle this guy one more time, off. Back on again, and at that very point the done bit turns off, turning off binary 3, and as soon as I turn this toggle off, CD will turn off as well. And again, if I hit this binary signal here, the reset, it will reset it to 0. So that's the premise behind the counter down. If you wanted to set up a program where it used a counter up, counter down, I can actually break into that real quick. I'm going to go into here, insert a rung. Maybe I'll just copy this rung and paste this rung here. Maybe I'll do that instead. That's faster. Faster is good. So I'm going to say, how about binary? I'm using 3, 2, 3, how about binary 4? And I'm going to talk to you, make you a counter up, and preset value, let's put it 10, all that business. Okay, let's go ahead and download that. Let's see how that responds to that. This is how Alan Bradley really designed the counter up, counter down to work. Unison with each other. One of the points that I will bring up to you guys' attention as we get further and further into this is that most often when I'm in a position where I need to count something, I usually use math. Counters can be a pain in the neck at times, trying to configure them properly and getting everything that you want in and out of them. So I almost always use math. And when we get to that point in the in the next section there, we'll be talking about that very thing. So anyways, so I'm going to come in here. I'm going to toggle this guy. Let's see here. I'll just come in here and toggle him a few times. T, 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 T. Done bits on. Okay, I got to toggle it 12 times. I'm going to come over here. Let's say I toggle this a couple times. Easy peasy, right? So I just toggle it. So you're watching the counter, same address, go up and down as it. So the premise behind it is you're counting, say, parts going into a machine, and the counting the parts going out of the machine. So now you've got a means to monitor the number of parts going in compared to the number of parts going out. They should be equal at all times, so this should work. But as you guys know as well as I do, there's also those challenges where things go wrong. And when things go wrong, you would like to have the ability to actually step back and say, how do I fix this? Because I got to readjust it. And that's where math really comes into play, is that when you're dealing with something like that, you're able to go right in there and make adjustments really easily. You can do the same thing with counters. I just have to address the .acc to get to it, and it's not hard. It's just a little extra step, and a lot of programmers kind of veer away from counters just because of that. You know, you're messing with the .acc words, and they can be a little problematic at times. So that's the counter ups, counter downs, timers, all of that for this section. So if you struggle with any of those pieces, just let me know. We can definitely work out the details. Okay, we'll talk later. Bye.